we present content flow bar, an intelligent user interface component that allows efficient navigation and previewing of videos. This is a joint effort by UCL Centre for Artificial Intelligence and University College London Interaction Centre. The information we seek sometimes can be embedded deep within long documents, such as videos, podcasts, or long PDFs, which are usually presented to us as hundreds of items in result sets. Finding the information we want and digging deeper can be overwhelming. When we look at previous literature, conventional search engines use titles, descriptions, and keyword highlighting to help us make relevance judgments. When it comes to informational content, proposals such as tile bars allow us to preview the concepts that are composed in a content. Also, things like word clouds allow us to summarize and preview the informational content within materials. When it comes to previewing videos, which is the focus of our work, conventionally, features such as title, description, and thumbnail are used for previewing. But when someone wants to look deeper into a video, usually they can hover over the timeline to see thumbnails generated from different time frames of the video, which provides a visual cue or a visual preview. Recently, when it comes to informational videos, there have been developments of fragmenting and annotating fragments of videos with informational content. However, this heavily relies on human annotation, which is not scalable. To address these challenges, we propose Content Flow Bar, a novel intelligent user interface tool that automatically fragments and annotates fragments of videos with Wikipedia concepts. So what is Content Flow Bar? What we have here is a search result for machine learning. As you can see, the Content Flow Bar replaces the timeline and allows us to preview into the topical contents of different parts of these materials. And as you can see, even when we go into the video, it allows us a glimpse of the different topics that are dominating in different parts of the video. This also allows us to non-linearly jump into different parts of the video, informed with the informational content. And as I mentioned before, Content Flow Bar is not just for videos. It can also be used with other long document types, such as PDFs. So how does Content Flow Bar change user behaviors? To measure this, we ran a user study with 26 participants. For the control condition, we gave a video player just like YouTube, where you can hover over the timeline and thumbnail previews of the different time frames will be provided to you. Then we had the treatment condition, where the Content Flow Bar was introduced in place of the timeline. Then we gave the participant 3 tasks. First, they would carry out a practice task where they would gather information about the brain. This task was for them to familiarize with the user interface and the system. Then there were 2 other tasks, one to gather information about climate change, the other to gather information about machine learning. We made sure that the participants did one of these 2 tasks with the Content Flow Bar off and the other with Content Flow Bar on. The experimental design made sure that we would gather groups of participants who would carry out different tasks with different conditions. We ran the interaction log analysis using behavioral signals coming from 4 main verticals: time, activity, navigation, and selection. Our objective was to analyze how the control condition varies from the Content Flow Bar condition in terms of these interaction metrics. We decided to use a paired hypothesis testing mechanism to validate this. Due to the small number of participants, we used the Wilcoxon signed rank test. In our initial analysis, we saw that there was a clear difference between the behavior when people did the climate change task versus the machine learning task. This is due to the topical differences of these 2 topics. To address this, we built synthetic pairs for paired testing, where we would take the controlled session from one participant and randomly match that with the content flow bar session of a different participant with the same topic. This way we would make synthetic pairs. In order to assure the robustness of our result, we did the random pairing 5 times and took the average. The result of this statistical analysis is shown here. The follow-up survey also demonstrated that majority of the participants agreed that the newly introduced video player was intuitive to use and it enhanced their experience in terms of seeking for information in the tasks. Taking the results into account, the conclusion is that content flow bar definitely encourages users to preview the informational content in the collection of result sets before committing to playing videos, and it also enhances the overall experience of the information seeking process. Going forward, we want to investigate further about the correctness and relevance of the choices these users made. We also want to improve the correctness of entity linking itself to improve the quality of these topics. We also want to explore how we can contextualize and re-rank these topics within the context of a query and also integrate this to a learning environment where we can run larger studies. Thank you for listening to us. You can find the URL to our learning platform x5learn.org where you can try out the content flow by yourself. If you have any questions, please do not hesitate to contact us.